Your distributed FastMCP deployment is struggling with inconsistent response times because each server recalculates the same data independently. We'll configure a shared Redis cache that synchronizes responses across all your FastMCP instances, cutting redundant computations and speeding up user requests. The pattern uses ResponseCachingMiddleware with a distributed Redis backend. Here's how to set it up in just 3 lines.
From key value, AO stores, Redis import RedisStore. From FastMCP server middleware caching, import ResponseCachingMiddleware. Hash distributed response cache. Middleware equals ResponseCachingMiddleware. Cache storage equals RedisStore. Host equals Redis. Example, com, port equals 6379.
This demonstrates the pluggable storage backend pattern, where infrastructure concerns are abstracted behind a consistent interface. The code shows how FastMCP decouples caching logic from storage implementation, allowing you to swap between in-memory, disk, or distributed storage like Redis without changing your application code. What makes this distinctive is the uniform interface that hides backend-specific details while preserving features like TTL and encryption. The pattern works through dependency injection at the middleware layer, where storage configuration is provided during component initialization rather than hard-coded. FastMCP's middleware accepts any storage backend that implements the key-value interface, enabling runtime flexibility. This design follows the open-closed principle. You can extend storage options without modifying the caching logic itself, and the system remains oblivious to whether data lives in memory, on disk, or across a Redis cluster. This approach solves the production development parity problem by making storage swappable via configuration. You develop with in-memory storage for speed, then deploy with Redis for scalability, using identical caching logic. The trade-off is minimal. You gain deployment flexibility at the cost of understanding the storage interface contract. It's particularly valuable in distributed systems where caching, session storage, or OAuth tokens must be shared across multiple server instances. Let's break it down line by line.
From key value, AO stores, Redis import RedisStore.
Imports RedisStore and a sync Redis client for distributed key value storage. This handles cache persistence across multiple service instances, preventing cold starts and inconsistent responses.
From FastMCP server middleware caching, import ResponseCachingMiddleware.
This imports ResponseCachingMiddleware, FastMCP's built-in caching layer that intercepts and stores HTTP responses. It eliminates redundant processing by serving cached responses when possible, dramatically improving performance for repeated identical requests.
Hash distributed response cache. Middleware equals ResponseCachingMiddleware.
This instantiates ResponseCachingMiddleware, a FastMCP component that caches HTTP responses in a distributed environment. It intercepts outgoing responses, stores them in Redis, and serves cached versions for identical requests, eliminating redundant processing. Critical for high-traffic APIs where response generation is expensive.
Cache storage equals RedisStore, host equals Redis. Example, com, port equals 6379.
This configures Redis as the distributed cache backend. The RedisStore handles all cache operations across multiple servers, ensuring consistent responses and reducing database load. By specifying host and port, it connects to a remote Redis instance for shared caching. This closes the middleware instantiation. The parenthesis pair encapsulates all configuration, ensuring the ResponseCachingMiddleware is fully initialized with the RedisStore before assignment. Distributed caching pattern. The Redis-backed ResponseCachingMiddleware transforms FastMCP's caching from local ephemeral storage to a distributed, persistent layer, enabling shared state across server instances without changing the core tool interface. Network latency between your application and Redis becomes the new bottleneck, so benchmark with your expected payload sizes before committing to production. This pattern scales horizontally while maintaining the same simple caching interface developers already understand.
The cache that forgets nothing remembers, only what it's asked.